This is lesson 4 in unit 8. We're talking about rational expressions today. And you can see in my vocabulary example, a rational expression is the quotient of two polynomials. And I've given you 2 examples here. Then in simplest form, when we have the numerator and the denominator are polynomials and they have no common divisor other than 1. So I've made up this example and I want to remove the common divisors x minus 3. Then what remains is the numerator and the denominator have no common factors, and this is the simple form. And we also want to consider our restrictions on the domain. We would not be allowed to have -3 or +3 since those two x values would cause division by 0 in the original problem. In this final example, an equivalent expression is when, similar to the simplest form, when we can factor the numerator and denominator separately and remove any common factors and then state the domain restrictions. So again, I'm going to take out the common factor x plus 2, and that will leave us x minus 3 in the numerator and x minus 1 in the denominator with domain restrictions at +1 and -2. So these are equivalent expressions. This simplest form is equivalent to this original problem here. In example 1, we want to be able to simplify. Well, let's answer this question. How do you determine where an expression is undefined? And you can write something in your own words. I'm going to say we can determine an expression is undefined where the denominator is equal to 0 in the original expression. 0 in the original expression. So let's jump right in. On example 1, we want to find the simplest form for each expression and state any restrictions on the variables. In the first one, if we use prime factorization or just kind of simplify, I see x cubed in the numerator and x squared in the denominator. I know I'm going to be able to eliminate an x squared. And the same thing with the y. I've got y cubed in the denominator, but I've got y squared in the numerator. So we can take out a 7 and an x squared and a y squared. Oh wait, I didn't do the x's, did we? Oh yeah, okay. So that leaves us with 4 in the numerator and that -1 in the bottom. So we'll say that's -4x, and we only have a y in the denominator. So this is simplest form, but back to the original problem, we want to look up here. X squared can't be 0, so x can't be 0. And y cubed can't be 0, which means y can't be 0. So those are our 2 restrictions on that expression. In part B, factors of -8 that add up to +2 would be +4 and -2. And in the denominator, factors of 6 that add up to -5, we would need to have a negative times a negative. So 3 times 2 would work. Then we could take out the common factor of x minus 2, and that would leave simplest form as x plus 4 divided by x minus 3. And then the restrictions come from the original problem. I'm looking here. So we have restrictions at +3 and +2. So those are our restrictions. And then our last example with 12 minus 4x. If we factor out a -4, that leaves us with x minus 3 in the numerator. And the denominator is the difference of 2 squares, x plus 3 and x minus 3. So we can remove that x minus 3 over x minus 3. And simplest form would be negative 4 divided by x plus 3. With our restrictions coming from here. So x can't be negative 3 and x can't be positive 3 based on the original problem. Next, we're going to jump into operations. First, we'll consider multiplying. So to multiply two rational expressions, you multiply numerator times numerator and denominator times denominator. So 5 times 12, let's rewrite 12 as 3 times 4. And then we got x cubed and y. So that could remove a 3 over 3. And an x squared could take out 2 x's and leave 1 x in the bottom. And then the y's could be eliminated. So we're looking at 7 divided by 5 times 4 times x. So 7 divided by 20x would be simplified. And the restrictions back here from the beginning, x is not 0 and y is not 0 for our two restrictions. In part B, we have 3 times the quantity x minus 2, and that's divided by the difference of two squares, which would let us take out that x minus 2 factor from the top and the bottom in the first fraction. And then the second fraction has x plus 3 times x plus 2 for the factored numerator. And then x plus 3 times x minus 1 for the denominator. We're going to remove that common factor, the x plus 3 terms. And then we can also remove this x plus 2 in the first fraction from the x plus 2 in the second fraction, which simplifies down to 3 in the numerator and x minus 1 in the denominator. So there's our simplified term. But we've got to consider all of the situations that give the original expression 0. So looking at factored form across the bottom, I see we are not allowed. I'm looking like here, 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 and here. We're not allowed to have negative 2, positive 2, negative 3, or positive 1 for our restrictions. So multiplication, multiply numerators times numerators and denominators times denominators, simplifying as you go along. But dividing two fractions, we want to multiply by the reciprocal when we're dividing two fractions. So the first thing we're going to do is look at 7x divided by 4y cubed would be the same as multiplying 8y divided by 21x cubed. So if we want to take out common factors, you can rewrite it just for easy to see. 7 times 8 times x times y, and then 4 times 7 times 3 times x cubed times y cubed. So this one I'm taking the approach of just expanding every term out and then eliminating common factors. 7 over 7, 4 over 4, take out a pair of y's. And what are we left with but 2 in the numerator and 3x squared y squared for the denominator. Back to the original, looking at the restrictions, y can't be 0. And since, if you think about it, this entire thing is a denominator, this entire expression is a denominator, So in the same vein, x can't be 0. So x can't be 0, and you can see that again here. X can't be 0, and y can't be 0. So the division restrictions are a little more complicated. You just have to be careful as you go along. In part B, if we factor, you've got x plus 4 times x plus 1, and then x plus 4 times x minus 3, and we're taking out the common factors there. Then we're dividing by x plus 1 times x minus 1, and then a 2x times an x minus 3. So let me be careful with what I'm trying to show you on these restrictions. This entire fraction, the entire expression, is a denominator because this is my numerator over here. Numerator divided by denominator. But I also have to consider these terms as a denominator in the numerator. So if we look at the restrictions first, let's do those first. So we're not allowed to have negative 4. We're not allowed to have positive 3. And then over here we can't have positive 1, negative 1, 0, or 3 again. So no 0, no positive 1, and no negative 1. That way we've taken care of all of those restrictions. Then we can move on to simplifying. Now we're dividing x plus 1 divided by x minus 3. And to divide, we want to multiply by the reciprocal. 2x times x minus 3 is the numerator, and plus 1 times x minus 1 is our denominator. We're going to simplify, and then we'll multiply straight across. 2x in the numerator and x minus 1 in the denominator, with all of these restrictions that we found originally. Example 4 says a toy company is considering a cube or a sphere-shaped container for packaging a new toy. The height of the cube would equal the diameter of the sphere. And we want to compare the volume to the surface area ratios of the two containers to determine which package would be more efficient. So if the height is S on the cube and the diameter of the sphere is 2 times the radius, then the S would have to be equal to the 2R. So the height equals the diameter. That's what they're telling us here. Height is equal to the diameter. And we want to compare the volume to the surface area. So first let's think about the volume to the surface area of the cube. So the volume is s cubed and the surface area is 6s squared. Simplified, that gives us s over 6 because we're taking 2 out here and leaving 1 in the numerator. And then the volume to the surface area for the sphere, doing the same thing for that shape, volume is 4/3 pi r cubed, and we're dividing that by 4 pi r squared. In that case, we can eliminate an r squared and a pi and an r squared and leave an r. We can also eliminate a 4 and a 4. So that ratio is r over 3. And remember that s is equal to 2r. So if we come over here and look at this, if s over 6 can be rewritten to be 2r over 6, and 2 divides 6 evenly, then r over 3 is the same thing as the volume to surface area of the sphere. That tells me that the volume to surface area ratios are the same. So if volume to surface area are the same, then the two shapes are equally efficient. So it wouldn't matter which they'd used. They would both work just as well. So they're equally efficient since they're related. Our last 4 problems are just exercises and practicing what the lesson topic is with multiplying and dividing. So we can jump right in with factoring this first set of fractions. X minus 2 eliminates. It's a multiplication problem. We can factor a 3 from the numerator. And then again eliminate the x plus 6 factors, and multiplying straight across 3 times x plus 5 divided by x plus 3, and we're wanting the denominators to not be 0, so our restrictions come from just the denominators of the two fractions, not having negative 6, positive 2, or negative 3 in this case. Whoop, left off the negative. Negative 3. So those are our restrictions. In 5b, we've got a division problem, so we want all of the restrictions to come from this fraction and this denominator. So that's where our restrictions are coming from. Just keep that in mind as we work. Numerator factors to be x minus 5 times x minus 2 divided by x minus 5 times x minus 3. And already we can take out the x minus 5. And dividing by, pulling out a negative here, so x plus 2 and x minus 2. If you think about that, that's negative x squared minus 4. So I can factor it as the difference of 2 cubes. And the denominator is x plus 6 and x minus 3. Then we're going to write that as multiplying by the reciprocal now that we've simplified it. So x minus 2 divided by x minus 3, and I'm multiplying by x plus 6, x minus 3, and x plus 2, x minus 2, and be really careful, don't forget the negative 1. So you can put the negative 1 in the denominator, or if it helps you keep track of it, you can also put that negative 1 in the numerator. I prefer the numerator. We can eliminate the x minus 2 here, as well as the x minus 3. That leaves us with a negative times the quantity x plus 6 divided by x plus 2. So this is my simplified form, and we want the restrictions, but remember where the restrictions are coming from. There's this one, negative 2, positive 3, negative 6, positive 5, and positive 3. So we'll jot those down. We've got not 5, not 3, so I took those from these two, and then all of the terms from here, all of these. X not negative 2, x not positive 2, x not negative 6, and we already had the 3 from the other side. Then our last two examples, we've got 8x squared y over x plus 1. And this fraction we're going to multiply by the reciprocal x plus 1 divided by 6x y squared. So x plus 1 can be eliminated, and then we can take out 1x from the top and the bottom, and 1y from the top and the bottom, which is going to leave us with 8x in the numerator and 6y in the denominator. And if we reduce those two down, 2 divides both of those evenly, we end up with 4x divided by 3y in that complex fraction. And our restrictions are going to come from everything down here and the x plus 1. So we've got restrictions for this complex fraction. We can't have -1. We can't have 0. We can't have y be 0. And I think that's all. So our final question here on part B, factoring the numerator, is x plus 1 times x minus 1. Factoring the denominator is x plus 3 times x minus 3. I'm going to write it sideways here. Factoring the denominator's numerator is x plus 4 times x minus 1. And then the denominator of the denominator, x plus 5 times x plus 3. That way we can see restrictions come from here and here and here. And then simplifying as much as possible, we've got x plus 1 times x minus 1 divided by x plus 3 times x minus 3, and then multiplying by the reciprocal gives us x plus 5 and x plus 3 in the numerator, and x plus 4 times x minus 1 in our denominator. That eliminates the plus 3's and the minus 1's. And I believe that's it. So that gives us a simplified version for x plus 1 times x plus 5 divided by x minus 3 times x plus 4. And I guess if you wanted to multiply that out and make it 2 trinomials, you could. But I'm going to go back up here and look at the restrictions. We have restrictions at -3 and +3. We have restrictions at -4 and +1, and a restriction at -5 and -3 again. So these are our restrictions. And that, my friends, is the end of lesson 4 with rational expressions.